Hello and welcome to Down to Earth with Terry Virch, where we talk about what matters down here on planet Earth. If you love the podcast, please subscribe and give us a rating. Today, I am super excited to have an amazing guest. Dr. Avi Loeb is the head of the Galileo Project, the founding director of Harvard University's Black Hole Initiative, the director of the Institute for Theory and Computation at the Harvard-Smithsonian Center for Astrophysics, and the former chair of the Astronomy Department at Harvard University, among many, many other accomplishments. He's also the best-selling author of the book Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, and a co-author of the textbook Life in the Cosmos, both published in 2021. Dr. Loeb, thank you so much for coming on the podcast.
Thanks for having me. And I should say, you should have said at the beginning, a farm boy.
And a farm boy. From Israel, were you a farmer in Israel? Is that your background?
Yeah, I mean, I grew up on a farm. I wouldn't say I'm a farmer, but
Right.
It was always plan B if I didn't succeed in academia. And
Right.
I'm not sure that I made the right choice, actually. Being connected to nature is a very relaxing experience. That's pretty much what I'm trying to do as a scientist, listen to nature rather than to people.
I had a chance to visit Israel a couple times. Unfortunately, I was the family escort for the STS-107 Columbia mission. And when the crew was killed, I went over for ceremonies for Ilan Ramon, who was Israel's first astronaut. And I fell in love. Israel is the land of milk and honey. I always thought it was the desert, and the farming there is unbelievable. It's a beautiful green country. The Sinai is desert, but there's a lot of really green places there. I was shocked.
Right. The one thing about reality, you often wish that reality would be better, but the way to make the future better than the past is to work at it. It's up to us. And if you have an ambition to make milk and honey out of this land, then you can do it. So that's a lesson for all of us.
The people of Israel have definitely, through the work and farming, I mean, it's a beautiful country. But one of the things that I want to start off with, I have a long list of stuff. I was researching all the incredible number of articles you write. That's impressive. But I want to talk about probably what you're most famously known for, this object that came to our solar system back in 2017. And how do you pronounce it? Is it ʻOumuamua, or how do you pronounce that?
ʻOumuamua. It means the scout in the Hawaiian language. It was discovered by Pan-STARRS, a telescope in Hawaii.
Right.
The Haleakala. And
right.
The name means a scout or a messenger from afar, because this was the first object unbound to the sun that we found near Earth. And it's roughly the size of a football field. And, we previously did not have a telescope that could detect objects as small as a football field by the reflection of sunlight from them. And if you think about it, NASA never launched a spacecraft as big as a football field. So for us to, find this object and then realize that it's not like a typical rock that we have seen before, I think it's quite remarkable. There may be many more objects smaller than it floating through the solar system. And the fundamental question is, maybe some of them are artificially made. Maybe some of them are plastic bottles among all the rocks that we find in our neighborhood.
Well, and I'm not an astronomer, although had I not gotten into the Air Force and been an F-16 pilot, I was going to go to study astronomy. That was like what I wanted to do. And there was a few things really interesting about this. If I remember right, the shape is really not normal, and also it accelerated without leaving a trail behind it. So there's some really strange things here going on, right?
Right. So astronomers that discovered it initially assumed that it's a comet, and gave it a comet, the name of a comet. And a comet is just an icy rock, a rock covered with ice. So when it gets close to the sun, the ice evaporates and you get a trail of gas and dust around it. The only problem was there was no such trail. We couldn't see anything. There was no cometary tail. So definitely not a comet of the type we are used to. And then people said, okay, well, maybe it's just a rock. But as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. And that meant that it has a very extreme shape, and most likely a flat shape, pancake-like, based on the variation of light. And that's quite unusual because it had to be at least 10 times longer than it is wide, and we've never seen something like it. And then it was pushed away from the sun by some mysterious force, which couldn't be the rocket effect from evaporating gases, because we haven't seen any gases. So the only way I could explain that was the reflection of sunlight is pushing it. And for that, the object had to be very thin, sort of like a sail. And I reasoned that nature doesn't make sails, so maybe it's artificial. And then in September 2020, there was another object that exhibited similar qualities. It was given the name 2020 SO, discovered by the same telescope in Hawaii, no cometary tail, and a push away from the sun by reflecting sunlight. And then a few weeks later, the astronomers who discovered it realized, actually, it came from Earth. If you trace the orbit back in time, it's a rocket booster that was launched in 1966 as part of Lunar Lander Mission 2. And we know that we produced it artificially. NASA launched it, and it had very thin walls. And that's why it had a large area for its mass, so it could be pushed by reflecting sunlight. But it wasn't designed to be a sail. The only question now is if ʻOumuamua and this object are both artificial, who produced ʻOumuamua?
Right. Is it, have you ever read Arthur Clarke, Rendezvous with Rama?
Yes. And in fact, I should say, in that book, which is now considered to become a film, actually, in Hollywood, there is a cylindrical object that showed up. So first, ʻOumuamua was most likely flat, but actually the name Galileo is derived from the northern part of Israel, Galilee, and means in Hebrew cylinder, actually. And I just, as you mentioned, I'm the head of the Galileo Project, and we can talk about it more later. And it's an interesting connection between Rendezvous with Rama, which was a cylindrical object, and the name Galileo.
Right. It was my favorite book as a kid, and I just read it again recently. I actually wrote a blog about my science fiction, and that book's amazing. But this cylinder comes through the solar system. It's an interstellar velocity, and we're like, And at the time, we have rockets, so we send some astronauts to discover this. I don't want to ruin it, but this interstellar spaceship. It's a really cool book. And as soon as I heard about this in 2017, as soon as I heard about it, I was like, that thing is Rama. That's what this is.
I never knew about the Rendezvous with Rama, the book, when I wrote, for example, my scientific paper about ʻOumuamua, but someone pointed out to me this interesting connection. And it only illustrates that Arthur C. Clarke did not just have imagination. He was a brilliant person in forecasting something like it. And Jules Verne forecasted the submarine, and these are people that had the insight into the future. And I should say, the world of possibilities, the world of ideas is infinite. There are an infinite number of virtual realities that we could be living in. One of them is that we are at the center of the universe. Okay. And people like those virtual realities that flatter their ego. The virtual reality that we are at the center of the universe was advocated by the ancient Greek philosopher Aristotle, and then when Galileo Galilei argued, I don't think it's the right one. It's not the actual reality we live in, by looking through his telescope. And he asked philosophers at the time to look through his telescope. 1,000 years after Aristotle, they refused because they thought they know the answer. That the Earth is at the center, and they put Galileo in house arrest. Today, they would have canceled him on social media. And if you were to ask those philosophers to design a rocket that would reach Mars, they would never reach that destination because they thought that Mars moves around the Earth, and that's not the reality that we live in. So my point is, it's really important to figure out which reality we live in. You can believe in virtual realities, convince everyone around you, put a person who claims otherwise in house arrest so that others will not listen to that person. But at the end, the Earth continues to move around the sun, irrespective of what you think.
Right.
And I had an interview with William Shatner, who was Captain Kirk on the USS Enterprise in Star Trek. And I told him, William, you probably you are the best person to appreciate the difference between the actual reality that we all share and a virtual reality that looks very attractive, because you played the role of Captain Kirk in this fictitious story on Star Trek. I never liked Star Trek because it violates the laws of physics, and I have a problem enjoying such a storyline. But at any event, I told him, half a year ago, you flew into space, and it was probably a very different experience, the actual reality compared to the virtual one. And he completely agreed with me.
Yeah, I agree. He's right. I mean, when you see things like this for real, you can't imagine it. Like, it's so profound and beautiful. It's just something that you can't imagine. That's so cool. You got to interview William Shatner.
Yeah, he asked me to, and the reason he did is because I took part in a forum at the Washington National Cathedral on November 10th with the Director of National Intelligence, Avril Haines, with Jeff Bezos, with the head of NASA, Bill Nelson.
Right.
And then when Jeff Bezos spoke, he said that he was inspired by Star Trek as a kid, and that's what led him to eventually promote space tourism with his wealth. And I told Avril Haines, who was sitting next to me, the Director of National Intelligence, I said, I was never impressed by Star Trek. I never liked it because it violates the laws of physics. And she said, we need to work on you, Avi. And I mentioned it in a commentary that I published in The Hill. And the same day, I got this request for an interview with William Shatner.
That's amazing. How cool is that? I've written one or two things for The Hill, but I never got a request from William Shatner or anybody like that. So I like to talk about both sides. So there's this potential that this object has a shape that you don't see in nature. It accelerated in a way that we don't know how it happened. And it's the first thing we've ever seen at an interstellar velocity. But there's this quote from Sagan, extraordinary claims require extraordinary evidence. And I think there's a general tendency in the astronomy community, which is probably a good one, that your first reaction is it's not aliens, right? So what are the counter arguments that this is a natural thing? What would other scientists say?
Well, first of all, I should say I don't agree with Carl Sagan. If I had to phrase it, I would say extraordinary evidence requires extraordinary funding.
I read that article. That was very good. Yeah.
Because if you look at, for example, the detection of gravitational waves, by no means was that the discovery of gravitational waves revolutionary for our daily lives. But nevertheless, to detect such waves, you needed to build the LIGO experiment at the cost of $1.1 billion by the National Science Foundation. And that project encountered a lot of resistance. I sat for an hour and a half on a flight with Ray Wise, the professor from MIT, who pioneered this project. And he told me the story that people at MIT, his own physics department, were opposing this project. They said it will never come to fruition. It will never be feasible. And I heard from the president of Harvard University, Larry Bacow, who was on the higher administration at MIT at the time, that when he consulted with colleagues of Ray Wise at the physics department, they said nothing will come out of it. Don't fund it internally. Don't support it. And then, fortunately, there was an administrator at the National Science Foundation who supported it. And eventually, the National Science Foundation invested a huge amount of money in the project, and it came to fruition. And then in 2015, they detected the first gravitational wave signal from the collision of two black holes at the edge of the universe. Now, just 2 years before that, I gave a lecture at a winter school to students of astronomy about gravitational wave astrophysics. And 10 minutes into my talk, one of the other lecturers at the school, younger than me by 20 years, stood up and said, why are you wasting the time of these students on a subject that will never be important in their careers? And 2 years later, the first gravitational wave signal was discovered. And then the Nobel Prize was awarded in 2017 to the LIGO experiment. So what's the moral of the story? The moral of the story is that there is a huge amount of resistance to innovation in science, and that there must be a lot of babies that were never born. LIGO is a baby that was born.
Right.
And we can all be proud of it and give it the Nobel Prize. But my question is, how many babies that were, that deserve to be born were never born because of this acidic intellectual atmosphere?
Yeah.
And the point of the matter is that the progress in science is led by evidence. It should not be led by prejudice. So when you see an object that is unusual, you shouldn't say, oh, it must be a rock. We don't care what it is exactly, but it is a rock, which is pretty much the attitude adopted by my colleagues, because there was a paper published, a review paper in Nature Astronomy magazine by experts who worked on rocks for decades. And they said, Oumuamua must be natural. There is no way out, it's natural. And then a few months later, a team of astronomers published a paper saying, well, in order for it to be natural, it has to be a hydrogen iceberg, because we haven't seen a cometary tail and it was pushed away from the sun. And the problem with that is that a hydrogen iceberg would get evaporated very quickly along its journey. It wouldn't survive interstellar space. So then another team came up with an explanation. Maybe it's a cloud of dust particles. And then the problem with that is, if it's 100 times less dense than air so that it will be pushed by reflecting sunlight, then it wouldn't survive coming close to the sun, because there it gets heated by hundreds of degrees and it doesn't have the material strength. So then another team came up with a nitrogen iceberg suggestion that was chipped off the surface of a planet like Pluto. And there the problem is, the mass budget doesn't give you enough chips to explain an object like Oumuamua. So my point is, if it was obvious to this group of experts that claimed it must be natural based on authority, then why would you need all these other groups to come up with specific explanations that invoke something we've never seen before? That to me shows that it was not obvious that it's natural. And if all of these things that we've never seen before are the best candidates for explaining the anomalies of Oumuamua, we should leave the possibility that it's artificial on the table and get more data, which is pretty much what the Galileo Project that I'm leading aims to do. Now, if you say extraordinary claims require extraordinary evidence, and at the same time you say it must be a rock, then what that means is that you don't fund the search. And if you don't fund the search, it's a circular argument, because it's just like sitting at home and saying, I don't hear a knock on my door, therefore I don't have neighbors. Or like Enrico Fermi asked, where is everybody? Now, obviously, if you are a fisherman, you're sitting on the beach next to the ocean and you say, where are all the fish? I don't see anything. If you don't use a fishing net, or if you're not looking through the windows of your home rather than sitting on the couch, if you don't use a telescope to look out, you may never find that you have neighbors, because maybe they would knock on your door, but when you're not at home, recorded human history is only less than 10,000 years old. It's 1/1,000,000th of the age of the Earth. If they travel across interstellar distances, takes a huge amount of time. Why would they come and visit you exactly when you're watching and come to Los Alamos to declare that they are here? I mean, they might use technologies that you don't even recognize. So, you need to use telescopes to look around before you say, where is everybody?
So that's what Galileo is doing, right? Can you explain that project?
Yeah. So basically, after I wrote my book, Extraterrestrial, I had, by the way, about 2,000 interviews over the past year as a result.
Thank you for doing this.
The book was translated, my pleasure, to 25 languages and became a bestseller in many countries. But the main point is a lot of interesting visitors came to the front porch of my home. And I hosted them at the porch simply because of COVID, the open air without a mask, it was not needed. And some of them were multi-billionaires. And then after being inspired by the book, in July 2021, they decided to give me about $2 million to the research fund that I have at Harvard. And at that point, I could establish a new project with $2 million. And the Galileo Project. We announced it with Frank Laukian, one of the early funders. He's the CEO of the Brooker Corporation for Scientific Instrumentation. And by now we have more than 100 scientists engaged in this project. And the project has two primary goals. One is to identify the next Oumuamua and send a camera that will come close to it, because a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. I wouldn't need to write the book if we had a high-resolution megapixel image of Oumuamua, and we could tell whether it's a hydrogen iceberg, a nitrogen iceberg, a dust bunny, or actually
a spaceship. Right.
Yeah, it has buttons on it, or screws and bolts. So it's not a philosophical question. We just need a high-resolution image. And for that, you need to come within 1,000 kilometers of an object like that, this size. And then one branch of the Galileo Project aims to design a space mission that will do the job. And it will cost about $500 million. Of course, it's quite expensive. So it's dating the next Oumuamua is an expensive date. The original Oumuamua looked very interesting. Like you go on a date, you see an interesting person, and then the person disappears from view. Right. You realize, okay, I want to date the next Oumuamua. In this case, we have to choose very carefully,
right? Because
if we end up choosing just a regular rock, we may spend $500 million for the just learning about a rock. At any event, that's one aspect. And then the second branch was inspired by the report of the Director of National Intelligence, Avril Haines, to Congress on June 25th, 2021. And that led actually 6 months later to the establishment of a new office in government that was legislated by Congress and signed by President Biden, and will start operations by June 2022. And this office will coordinate the assembly of data on unidentified aerial phenomena. These are objects whose nature is unclear, and the government is not clear about what they represent. They don't seem to be made by humans necessarily. I mean, it's not obvious, and they are not necessarily natural phenomena, so it's under study. And at the time, just before this report came out, Bill Nelson, the head of NASA, said that scientists should look into these and try to figure out their nature. And that inspired me to establish the second branch of the Galileo Project. And our goal is to build telescope systems that will identify the nature of those UAP. And the first system will be built on the roof of the Harvard College Observatory in the coming months of spring 2022. And then it will be made of, we will have cameras monitoring the sky nonstop, taking a video of the sky in the infrared and in the optical band. So in the infrared means that we can observe objects at night, even just based on the heat that they emit. We don't need the sun to illuminate them. Right. But then we will have an optical camera looking at the entire sky with a fisheye lens that could see objects during the daytime. And these are instruments that will give us much better data than the publicly released government data. I'm sure the government has higher resolution images that they haven't released because the sensors that were used to take them are classified. But the sky is not classified, and we will collect as much data as we can. And we will also look at the radio and the audio, and then have our
audio. Yeah, you'll listen to sound.
Yeah, infrasound from very low frequencies below a hertz, like 0.05 hertz.
Oh, wow. Yeah.
Tens of kilohertz. And the idea is, or hundreds of kilohertz, the idea is to see, detect the object in all possible ways. Also, we will have a magnetometer to detect fields. And the data will be analyzed by artificial intelligence algorithms that use machine learning to figure out if we are looking at a bird or a drone or an airplane or something else. And once we are happy with the performance of the first system, we will make copies of it and distribute them in many locations. And the number of copies we make depends on how much funding we have. So currently, with the $2 million that I have, we can maybe build 5 to 10 such systems. But the goal is to get $100 million so that we can get hundreds of telescope systems and get a good enough sensors of these objects, the UAP. And I should say the other development of the past couple of weeks is that we are partnering with Planet Labs that has a fleet of 210 satellites monitoring, taking an image of the entire Earth once a day. And we will try to look at unidentified aerial phenomena also from above, not just from below, using satellite data. And that would be very exciting. That data will be analyzed earlier than the data from the telescopes.
I could see from the space station, you'd see little trails of streaks. They were meteors, right? So you're used to seeing that. Sometimes it looks like a shooting star, but you can see that from above, but it's like a fiery trail below you. And at first I was like, that's cool. But then I realized that thing just flew past me on the way down to Earth. So, so you realize there's stuff out there.
As long as it moves on a ballistic trajectory, you know that it's a rock. But suppose it maneuvers, suppose it moves in a zigzag fashion or some unusual pattern, then it merits more attention.
Absolutely. Yeah. So this project is going to look in different spectrums, visual, even sound, infrared and radio. Are you looking for things in the atmosphere, or are you looking for ʻOumuamua flying out in space, or both?
Both. I mean, so the first branch of the project that I mentioned will be trying to find the next ʻOumuamua and get close to it with a camera. And the other branch is trying to look for things within the atmosphere or just above the atmosphere, much closer to Earth. Basically, we don't care where the object is as long as it looks unusual. We want to figure out if it's artificial in origin. And I should say ʻOumuamua was the size of a football field. There might be many more objects much smaller than it flying around that we haven't noticed so far.
I want to talk about all these UAPs that the Navy fighter pilots have seen. I've had Chris Mellon and Lou Elizondo and on the podcast. And
they are members of the Galileo Project, by the way.
Excellent. Chris, they're both great guys. Chris was Undersecretary of Defense. He ran the Senate Intelligence Committee. He's a very serious, well-educated, smart guy. He had an interesting hypothesis that and he's not saying that he necessarily believes it, but it's an idea that these objects that we're seeing are some kind of drones. They're not life. They're just, maybe an intelligent civilization sent out drones to the whole galaxy. Like in Star Wars, remember the Empire sent those little drones that were trying to find Luke Skywalker? They went to all these different planets. Maybe that's what they are. I don't know if that's true or not, but I don't know if you consider that.
Humans in particular were not designed to spend long periods of time in space. I mean, you spent some long time, 7 months, but actually the human body unprotected from cosmic rays, would not survive for more than a few years. Yeah. And that's why I find all these discussions about being on the surface of Mars as a little bit too wishful thinking. I don't think that's possible. You need to dig underground caves. Only there you will be protected, or put some shield around you. But at any event, the reason is simple, that the Darwinian evolution selected us to live on the surface of a rocky planet like the Earth. And we are not
with a magnetic field. With a magnetic field. That's why we're here. And Mars doesn't have that. Mars doesn't have that.
That and the atmosphere. The atmosphere also blocks the cosmic rays.
Exactly.
So we have this blanket that protects us. It's sort of like a womb, that we live in.
Right.
And the point is, therefore we shouldn't think about sending humans to long journeys in space like you find on Star Trek, but rather send equipment, and it better be intelligent. We have artificial intelligence systems driving cars, and in the future I can imagine AI astronauts, sending systems that are completely autonomous. Right now we have a robot, Perseverance, on the surface of Mars, but it's being operated by the Jet Propulsion Lab engineers. And what I would like to see is an autonomous astronaut made of computer chips, that is able to learn from experience and maneuver and do the things necessary to survive in space. And of course, the advantage is such AI astronauts can survive long journeys that could last billions of years because they're made of hardware. They can also have 3D printers that repair any damage caused to their equipment. But if I had to imagine a visit from another civilization, I would imagine in the form of equipment that could potentially be very smart. It could outsmart us. And in order to figure it out, we would need our own AI systems figuring out their AI systems. They might feel some kinship to other AI systems coming from afar more than we do.
Right.
We would. So I have no problems being proud of our technological kids. I don't want to send my own kids to space. I want to send AI systems that I will be proud of, that represent me. In fact, we can even equip them with the blueprint of what we want to accomplish in space with our set of values. And I should say I'm much more proud of that than, for example, New Horizons that we sent. That mission had a box inside the spacecraft that carried 30 grams of the ashes of Clyde Tombaugh. Mm-hmm. Now, if you think about it, Clyde Tombaugh is the guy the scientist who discovered Pluto. And this mission was aimed to study Pluto. And if you think about it, what are ashes? They are burned up DNA. So you take the genetic information about a person you want to commemorate and you destroy it. You burn it up, and then you put the ashes, which are no different than the cigarette ashes, in a box, and you put it on that spacecraft. Now, I'm very embarrassed by that, because if an extraterrestrial civilization finds it, they would ask, what are these primitive rituals that those Earthlings have?
Well, Voyager was better, right, with the record?
Yeah, a little better, but still, it's from the 60s. We have much better music now. So what I would like to do is send a spacecraft that moves faster than New Horizons, that overtake it and apologizes for this box of ashes and says, don't pay attention, that was from ancient traditions, but we actually are much smarter. And I do think that, if there is a committee out there in interstellar space that tries to evaluate whether there is intelligence near the sun, at this point in time, they might decide that no, not yet. Given if you look at human history, we haven't shown a lot of intelligence. The way I see intelligence is it's a sense of modesty, willingness to learn from experience, from evidence, and not thinking that you know the answer in advance, not trying to feel superior, arrogant. And if you look at human history, it's pretty much marked by attempts of some people to feel superior relative to other people. And the best example is the Nazi regime that triggered the death of 75 million people. That was 3% of the world population in 1940, and it's 10 times more than the number of deaths caused by COVID-19. And we've been talking about it for 2 years, just because a group of people decided to feel superior. And perhaps if we find a smarter kid on our block, we would realize that the differences among us are really meaningless, and that we should treat each other as equal members of the human species.
My fifth night in space, Avi, I was flying over the Mediterranean, and it hit me. You don't really see people during the day, but at nighttime you can see city lights, so you can see people. And the Mediterranean, there's Cairo and the Nile, there's Israel and Lebanon and Jordan and Syria and Turkey, and it's like it was right there. And I remember thinking, what is the problem, guys? You all live right next to each other on this giant, beautiful planet. It hit me. And when I went back, I saw North Korea a lot. And South Korea is this beautiful, vibrant country. Seoul is one of the brightest cities on Earth. And North Korea is a giant black hole with a little white dot where Pyongyang is. And, you can see politics from space. And to think about the goal of governments is just to keep themselves in power. There's a lot of the rise of authoritarianism really worries me a lot. I used to say it feels like the 20s and 1940s, not that far away. It kind of feels like the 30s now, and 1940s, not that far away.
Well, I should say that I visited Abu Dhabi for a conference organized by NYU when they established the new campus there. And even though I'm Israeli,
Which conference?
There was a conference that inaugurated the Abu Dhabi
Ideas Weekend?
NYU conference. Sorry?
Was it called Ideas Weekend? I was there a couple years ago.
No. That was a decade.
A decade ago. Okay.
When the new campus was established back then. And we had a tour guide who was bragging that you can see Dubai from space.
Mm-hmm.
It's so bright. They use the oil fields to illuminate. I was speaking with a colleague of mine from Princeton, Ed Turner, and saying, well, that's interesting. Can we see city lights far away? And then we wrote a paper about, how easy would it be for us to recognize artificial lights, not lights as a result of reflection of sunlight from objects within the solar system. And just a few months ago, we wrote a paper with an undergraduate from Stanford saying, next to the nearest star to the sun, there is a habitable planet. It's called Proxima Centauri, and the planet is called Proxima b, and it's in the habitable zone where you could have liquid water on the surface of this planet. But because the star is so faint, the planet is 20 times closer to it than the Earth is from the sun, and that is the habitable zone. And at that short distance, the planet is tidally locked. So it has a permanent day side and a permanent night side.
Right.
Faces the star always with the same side. And so if there is a technological civilization there, they would like to illuminate the night side. And we wrote a paper asking whether the James Webb Space Telescope can detect city lights on the night side. So if the night side is not completely dark, and we can detect it with the James Webb Space Telescope, that would illustrate to us that there is a technological civilization close to us. But of course, it's a challenge. It's very unlikely that the star next door will have such an advanced civilization. But nevertheless, it's an interesting thought. And the fact that you saw city lights from space implies that in principle, if we have sufficiently powerful telescopes, we can search for city lights on other planets.
The Webb telescope, I've had a couple folks on talking about that. It's going to look for chemical markers, they think, and do a spectrograph, I think, of the light. As the starlight shines through the atmosphere, you see water, there's a star shining through our atmosphere right there. So Webb can do that. I never thought of city lights, but that's a really, that's an interesting thing.
A few years after we wrote this paper with Ed Turner, I thought about another idea to detect technological civilization, which is, so future telescopes that will be built after the James Webb Space Telescope will try to detect, for example, oxygen or methane gases that are indicative of life. But the problem is that Earth, in the first 2 billion years of its existence, roughly half the current age of the Earth, didn't have much oxygen in its atmosphere. It had a lot of microbes, but there was not much oxygen. And so if you don't find oxygen, it doesn't say that you don't have primitive life in the forms of microbes. Earth is an example. And then if you do find oxygen, there are other ways of making it. So you need to rule out natural origins, chemical origins that have nothing to do with life. And on the other hand, there is a clear way to infer the existence of life, which is to find evidence for these complex molecules, CFCs, that refrigerating systems and industries are producing. They pollute the atmosphere. These are the molecules that destroy the ozone in the atmosphere.
Right.
If you detect evidence for those complex molecules for industrial pollution of planetary atmospheres, it will not only tell you that there is life there, but there is industrial life, and technological life. So in my mind, building those spectrographs that will aim to detect molecules like oxygen and methane, just for the sake of detecting those molecules, is not the best motivation. I mean, you may want to search for industrial pollution as well. And again, you don't hear that narrative. And I just don't understand why. Just like city lights, industrial pollution should be one of the goals of astrobiology. And there are other ways, of course, to detect civilizations, but the simplest of all is archaeology, just searching for objects that arrive to our vicinity, like plastic bottles on the beach. You find a lot of rocks, but every now and then a plastic bottle. And if we search, perhaps we'll find a message in a bottle.
That's an interesting analogy. Have you heard of another science fiction book called Three Body Problem?
Yes.
By Xixin Liu. So it's about Proxima Centauri, but there's three stars there, right? It's not a binary, it's a
triple,
whatever, three. Yeah. And it's an interesting book because the planet where the aliens live, since there's three stars, sometimes it's super cold, sometimes it's super hot, and the civilization wakes up occasionally. It's like cicadas. Anyway, it was a really interesting book. But the real problem, I think, and they deal with it with this kind of fictional, they use Jupiter as an amplifier, but is signal to noise ratio, right? These things are really, really, really far away. And the radio signals that we're sending out are really, really, really dim compared to the noise the sun makes.
Well, for 70 years, we've been searching for radio waves. And I think it's misguided because it's just like trying to have a phone conversation. You need the counterpart to be active when you're listening.
Right.
And if you look at us, we've been transmitting for 127 years since Guglielmo Marconi transmitted the first radio signal. And that's just 1 century in the lifetime of a planet that lived for 10 million times longer. And so the chance of catching another civilization using the same technology as we used over the past century is pretty slim. One of the reasons may be that we won't survive for more than a few centuries from now, given the self-inflicted wounds that we are creating.
Yes.
All with the climate change and other things. So my point is, this is the wrong strategy. A much better approach is to look for objects. And that was never practiced, even though people talked about objects, since the 60s. It was not searched for in a methodical way. And the subject was ridiculed and stigmatized. And to me, the wake-up call was ʻOumuamua, the fact that there is an object we discovered, the first one, by the way, which says something. If the first one looks so weird, we should really pay attention. And there might be
the first one wasn't just a normal asteroid.
Exactly. Yeah, or a comet. I mean, you expect most of the visitors from interstellar space to be comets because they are in the outskirts of the solar system. They can be easily dislodged by a passing star. So if you imagine objects coming from other planetary systems, they would most likely be those comets that are loosely bound to their star.
Kuiper belt objects.
Beyond the Oort cloud, actually.
Oort cloud, okay.
They are icy because it's freezing out there. They are icy. So that's why there are PRS long period comets. And that's what you expect from other stars. The innermost asteroids that have no ice on them, in order to kick them out of the planetary system, you need to give them a huge boost. And that is unlikely. It's, there are many more objects in the outskirts. So you would expect the first object, or actually almost all of them, to be comets. And the first object shows up, it doesn't look like a comet that we are used to. And so it's quite remarkable. And by the way, this object was pretty big, and there might be smaller objects of interest. So I think it opens up a window for exploration that was never practiced before. And to me, it's just like the poem by Robert Frost, who took the road not taken, and it made all the difference for him. For me, the main difference is if you take a path that others did not take, like exploring archaeology, trying in space, trying to find objects that were artificially produced, then there is a chance that you will harvest low-hanging fruit because nobody took that path. So there might be some low-hanging fruit. And in the Galileo Project, we might, within a year or two, find some really conclusive evidence for things that do not appear to be natural or human-made. And that is thrilling,
Oh, absolutely. It's new. I mean, that would be incredible. Are you looking, will Galileo have capabilities that we don't already have? Because there have been other full sky surveys, right?
Oh, definitely. No. So the point is that when you look at astronomical observatories, if a bird flies above them, they ignore it. They don't track birds.
Right.
Because astronomers are focused on very distant sources of light.
Right.
And as a result, these sources move very slowly across the sky. So nearby objects are of no interest. And in fact, astronomers ignore them. And now, most of the objects that move a lot on the sky are considered to be rocks, as we know from the experience with ʻOumuamua. But then ʻOumuamua had some anomalous properties. One of them, by the way, that I didn't mention is that it came from a very special frame of reference. It's called the local standard of rest, which is the frame that you get to when you average over the motions of all the stars in the vicinity of the sun. So every star has some random motion relative to the frame of the Milky Way galaxy locally. And this is called the local standard of rest. And Oumuamua was at rest in that frame. And you wouldn't expect it to be, because it should have inherited the motion of its parent star. And it didn't. Only 1 in 500 stars is so much at rest as Oumuamua was. So here again, you see the first object in a special frame of reference, which to me sounds really peculiar. And that's the frame of reference where you want to hide the origins of an object, right? Because if you don't want anyone that finds the object to know where it came from, you would put it in the local standard of rest, because there is no star there. You know, that is a frame of reference that no star shares, you know, only 1 in 500 stars or less. So you put it there, and whoever finds it, it's just like parking a car in a parking lot. You never know where it came from.
I did not know that. My next question was literally where you can trace its orbit back to the star it came from, but we can't.
No, you can't. And by the way, that's not a useful exercise anyway, because the Oort cloud of the solar system goes halfway to the nearest star. So it means if each star has an Oort cloud around it, it's just like densely packed billiard balls. So just imagine taking a random line through those densely packed billiard balls. Obviously, you will cross a lot of them in any direction. So there is no way, like people were trying to say, Oumuamua came from this or that star because it's pointing in that direction. No way, because in that direction, if you take the Oort cloud around every star, you would find a huge number of stars that are in that direction.
Do other stars have Oort clouds? Or theoretically, we assume so?
We don't know that, but if we think the solar system is typical,
right?
So then they should. But if you think about the origins of the Oort cloud, these are the building blocks of the solar system. So it's just like Lego pieces that were used to make up the planets, and there was some leftover. I mean, most of them were left over because they were not, you know, the process was not very efficient, you know, so there were lots of planetesimals left behind, and they were kicked gravitationally, and that's what made the Oort cloud that goes roughly halfway to the nearest star. Now you may ask, why halfway? Because, well, in principle, it went beyond that, but then the star near us kicked them out. So whatever was left was just the Oort cloud, and that's where the tidal force of the Milky Way galaxy, for example, removes objects from the solar system. So it's pretty much the largest distance out to which you can have objects bound to the sun. And that's where we find the edge of the Oort cloud.
But you said it's halfway to Proxima Centauri, so these objects are 2 light years away, bound to the sun.
Yeah, so it's quite remarkable. It's
wow, I had no idea.
They're extremely cold, and they move at a fraction of a kilometer per second, very slow speed, you know.
Right.
Actually slower than the speed of sound in the air.
Oh, wow.
And they, some of them are kicked or have an initial speed that brings them close to the sun, and we see them as long period comets. Because they are you know, they have ice, they come from very far away, they're frozen basically, and they're frozen embryos, planetesimals that were not incorporated into the planets that are in the solar system.
That's an amazing hypothesis. I did not know that. So there's one more thing I want to talk about. We're talking about all these alien planets and things. You had a very interesting article. I did some research before this interview, and you have 3 life lessons that you've learned. Happy birthday, by the way. And you have a big birthday coming up.
Yes.
Can you talk about those? Because those are pretty profound and very meaningful, I thought.
Well, yes. Well, I'm having my 60th birthday coming up on the 26th of February. And indeed, I came up with some life lessons, and I could summarize them in 3 broad brushes, so to speak. And so let me go over them one by one. so the first one, I think the most important one, is that, after both my parents passed away a few years ago, I realized that, life is too precious. So we should focus on the time remaining to enjoy, rather than on past accomplishments. So throughout most of my career, I was pursuing recognition and trying to impress gatekeepers and people on selection committees of awards, honors.
And you're right.
And then it's sort of like an addiction to a drug. You get completely attached to it, and you just work under the premise that this is the thing that gives meaning to your life, what other people think about you, and that's completely wrong. Rather than being proud of past accomplishments, we should focus on the time remaining for us to enjoy, and how to make the best of it, and not so much reminisce about the past. So that's my first lesson of life, which is, I think, very important. And it motivates you to create new things. If you are proud of the medals and you put them around your chest, the medals that you were rewarded in the past, then you become lazy and you don't do much. And that's the worst that can happen to a human. So let's focus on the time remaining and make the best out of it. So that also makes us more alert, trying to use it in a better way than we did in the past. And the second important lesson is to start each day from scratch, without prejudice, without arrogance, without feeling privileged. And once again, if you look at all the accolades that were given to you based on past performance, all these awards, you wear these medals every morning, then unfortunately that is the wrong approach to the day, because the only way for us to learn new things is with a sense of modesty, without having a prejudice and without feeling privileged. Just be modest. Every day is a learning experience. Try to figure out new things that you didn't know yesterday. And, that's the second lesson for life. And the third one is that money is only helpful in buying freedom. Beyond this, it's useless. And by that, I mean, I'm on a very specific diet, low carb diet, and I eat pretty much similar things every day. By the way, half of my calories every day are from dark chocolate.
Oh, wow.
No sugar, about 800, 900 calories every day. That's my sort of daily feast. But
wow.
The point is, if I have if I get more money, it wouldn't change my diet. I will eat the same thing. So you need some minimum to allow you to get the food, to get the clothing. I don't buy many clothes, maybe once a year or something. Or I need, of course, shoes and a place to live in, my home, and pay the rent or mortgage. So there are some fundamental needs, but beyond those needs, if you accumulate too much money, you have to worry about making more or how to take care of it, and that's actually becoming a burden. And what I'm trying to say is the most important thing in life is your freedom, your ability to do what you care about. And if you engage in ways to get more money, or if you engage in possessing as many things as possible, like a very expensive car, a very expensive home, a very expensive this and that, going on vacation, that distracts you from doing something meaningful, because these things are superficial. They don't contribute to a better understanding of the reality that you live in. And the way I see life is as an adventure, trying to experience new things, learn new things about the reality that we share. And money is not buying you that. There are lots of people that are very wealthy and do not have a clue about life. And so money is helpful in allowing you the freedom. Now, of course, if you have to worry about paying the bills, then that takes away your freedom. So that's what I'm saying. So there is a minimum threshold you need to overcome. Because up to that threshold, I remember as a young, adult, I had to worry about paying for things and like food and clothing and so forth. And that took a significant, non-negligible fraction of the time. But once you reach a certain point in life where you don't have to worry about these essential needs, then you're free. And unfortunately, a lot of people don't appreciate that. They put more and more constraints on their life by trying to get more money, and I think that's one of my lessons, that it's not needed. It's actually a distraction. And following these principles makes me happy. I'm happy to focus on the time remaining and do and follow adventures, like the Galileo Project. If within a year or two we find that we are not the smartest kid on the block, that would make my life, basically. That would give me meaning. It will change everything.
Yeah.
If it will also imply that everything that my colleagues advocated for, extraordinary claims require extraordinary evidence and so forth, and not funding the search for this, was a result of prejudice.
So can you talk about that? You wrote another article, very interesting, putting our science funding in perspective with our military budget. Right. I have a lot of thoughts there too, but yeah, talk about that.
Yeah, so President Biden signed into law the defense bill, defense budget, a month ago, and that was $768 billion dedicated to defending the United States against adversaries, other people. And if you think about it, it's a sort of a concern that is extremely important, national security. But in the big scheme of things, if there are other civilizations out there, it's just like kids playing on the playground, in the kindergarten with each other, and then not even being aware that there is a city outside of that playground.
Right.
Now, suppose suddenly a car would show up from that city and those kids would notice it. They would say, well, that is interesting. It's not like the toy cars we're playing with. And maybe we should learn more about that car. Where did it come from? What does it mean? Is there a city out there that is very different from the playground we are playing in? So imagine the political system deciding that this is a priority item, that we should allocate similar amounts of money that we allocate to national security to this question. So that would mean $1 trillion a year dedicated to science. Now, the biggest science project, like the Large Hadron Collider or the James Webb Space Telescope, they cost $10 billion over decades. And that was done by collaboration among nations. So We're talking about thousands of times more money than allocated to the biggest science projects ever given to this question. And what can we do with it? Well, we can build telescope systems bigger and better than the Galileo Project will employ. We can send probes to space that would explore our cosmic neighborhood. And we will reorganize human society, because when we realize that there is something beyond our playground, that is much more important, then our sense of priorities will change. So what I say is, let's think big. First of all, let's search for such equipment, rather than dismiss it, ridicule it, put it under a stigma, and not believe our fighter, jet pilots, military personnel that we usually trust. And it's not just them; it's former CIA directors and national, security
officials.
Yeah, and so people that looked at classified data that argue that it's real and important and mysterious, and it's the duty of scientists to attend to this question and figure it out. And that's basically my message, that this subject could gain importance by at $1 trillion a year funding level. Right now it's 1,000 times less than the biggest science projects are getting. So we are talking about 1 million times under value for the search. And my point is, let's be smart and intelligent and do the search. Only if we don't find anything, we can argue, okay, well, let's stop the search. But in science, for example, for 40 years, we've been searching for the nature of dark matter. We looked for particles that we've never seen before. and we haven't found them. So we invested even $10 billion in the Large Hadron Collider searching for one type of these particles, supersymmetric, weakly interacting massive particles. We haven't found that, but nobody says it was a mistake to search. And so I'm saying, let's invest similar funds in the search for equipment from other civilizations, because that's not an extraordinary claim. We exist. Half of the sun-like stars have a planet roughly the size of the Earth at the same separation. So it's quite possible that, you know, there was something like us 1 billion years ago that filled up the Milky Way galaxy with equipment.
Right. By the way, we have AMS-2 on the ISS that's looking for anti-helium, a dark matter, basically, right? That's Dr. Samuel Ting's. I got to not officially crawl on it, but I may or may not have touched it when I was on a spacewalk. So the ISS is helping in that search for dark matter.
Well, the anti-helium is more to do with the abundance of antimatter in the universe. You know, we are made of matter.
Right.
And early on, the universe was very hot. So there was roughly equal amount of matter and antimatter. And then matter annihilated with antimatter. There was a little bit of residue left behind, and that's what we are made of. And the question is, you know, how much antimatter is out there? And the experiment you mentioned is attempting to detect some antimatter to figure out, you know, how much there is.
Right. But I'm just a fighter pilot, but there was some connection with dark matter with that too, right? It was like,
because
it's an indirect indicator. Yeah,
dark matter can decay into antimatter, can produce it as a byproduct of collisions among particles that make up the dark matter. So yeah, there are many suggestions for the nature of the dark matter. We haven't found it. It's considered part of the mainstream of physics to search for dark matter. And, you know, I asked one of the experimentalists, how long will you search for a particular type of weakly interacting massive particles? And he said, as long as I'm funded. And 40 years. Here's my point. If for 40 years, the Galileo Project searches for equipment and doesn't find anything, and we invest hundreds of millions of dollars in the search, then in 40 years, we will be at exactly the same point as the mainstream dark matter searches are right now.
Right. By the way, that's a WIMP, right? Weakly interacting yeah, it's a WIMP.
Yeah, the other possibility for it was a macho. You know, that's a massive compact halo object.
Right.
Alternative to the WIMP. And that was also not found. We didn't find that the dark matter is made of objects roughly the mass of the sun.
Wow. Well, so physicists have a sense of humor with WIMPs and machos.
Yeah. I mean, one form of machos was black holes that were produced, you know, in the early beginning of the universe. So far, we didn't see, I mean, we rule out the possibility that dark matter is made of such black holes, yes.
So back to the comparison of funding levels, you know, we've spent several $1 trillion on these never-ending wars over the last 3 decades in the Middle East, several $1 trillion. Imagine, and there's not a lot of return on investment for what we've been doing there. Imagine there's so many things. I mean, infrastructure, there's other stuff too, but space exploration would be one. How much more benefit to all of humanity we would have had. And I'm an Air Force retired colonel. I'm also very aware that there's bad guys and we have to keep them in check. And if we just lay down our arms, these other authoritarian governments will take us over. I get that. But when you put it in perspective, we don't always make the wisest choices, I guess.
Yeah, I mean, my point is simple, that science is supposed to serve society in some sense.
Right.
There is also the question of trying to figure out nature, curiosity. But if you ask me, I don't want to spend my career on arguing how many angels can sit on the tip of a pin. Or another way to put it, I don't want to spend my career asking whether there are extra dimensions of the multiverse if I have no way of testing that experimentally. Okay. Right. And these are themes, not the angels, but the extra dimensions and the multiverse are themes of the mainstream in physics right now.
Oh yeah, it's string theory, right? Yeah.
And so the way I see it is, in some sense, we went too far in academia, where the mainstream is engaged in questions that are of mathematical curiosity, whereas questions that are of great interest to the public, like are we alone, are we the smartest kid on the block,
Right.
are being ridiculed. And you know, you can ridicule it, that's fine, but if there are clues that are intriguing, okay, that where the government comes forward and says, let's put some money into a new office in government that will explore objects we don't understand. And if the first interstellar object appears to be unusual, not like the rocks we've seen before, and pretty much, you know, the mainstream agrees to that, because all the proposals invoked a rock of a type that we've never seen before. So, okay, so if everyone agrees it's something we've never seen before, and there are all, so this subject begs further scientific inquiry. And how can
absolutely.
And to me, the critics of the Galileo Project, which are quoted, you know, in the in Science magazine most recently, they are arguing against this, and that's basically an argument against the scientific method, because collecting evidence on a subject of great interest to the public and following the scientific method on that is pretty much what scientists are supposed to do. And if there are people within academia arguing against it or ridiculing it or pushing against it, when the funding is coming from the private sector, then I say something is wrong. Okay.
Avi, you're a scientist, so you know this is the way scientists are. They bicker and fight and criticize. I mean, this is just kind of human nature.
Okay, so I'm a scientist, and that's not the way I'm working.
Well, I know.
And
I guess what I'm saying is not unexpected. If you're proposing to do something, somebody's going to criticize it, I would think.
Oh, yeah, for sure. I mean, you see that also in the tech world, but you know, you expect academia to be open-minded,
right?
You expect it to be willing to dare to go into territories that were not taken before. And what I want to argue is that in the tech industry, you find as much openness as you find in academia these days. And in the government, you find more openness on this particular issue that we just talked about. And by the way, you also find it among religious people. So there was an article that was about my book on the front page of an Orthodox magazine in Brooklyn, New York City. And then a colleague of mine at Harvard said, well, it looks like the Orthodox are more open-minded towards this question than your colleagues.
And, than the atheist astronomers.
Yeah, so my point is,
funny.
You know, I think when we find anomalies, when we find things that are unusual, then scientists should be intrigued by it, should see it as an opportunity to learn something new rather than a threat on their expertise, you know, because a lot of us want to pretend that we know much more than we actually know. And that's the thing that bothered me as a kid growing up. You know, I went to dinner and I would ask a difficult question, and the adults in the room would pretend they know the answer or would dismiss the question because they don't know the answer. And I was very frustrated because it was obvious to me that they do it just because they don't know the answer.
Right.
And I thought that by becoming a scientist, basically following my childhood curiosity, I would be surrounded by like-minded people that would be curious, will not be focused on themselves as much as on, you know, on trying to figure out nature.
Knowledge,
you know,
right.
It's not about doing intellectual gymnastics, that we are smart. It's not about talking about the multiverse just to show that we can manipulate mathematical equations. You know, nature could be really simple. Suppose we find that ʻOumuamua was not a rock, just by getting a megapixel image of it. Suppose we find that it's, you know, a technological object that we didn't produce. That doesn't require very fancy math. It will not demonstrate that the person who took that picture is very intelligent. It just, you know, the person just needs to be an engineer that designs a camera that passes within 1,000 kilometers of this object. That's all. And my point is, we will learn something really fundamental about nature when we do that, compared to doing mathematical gymnastics about extra dimensions and multiverse that we would never encounter in our lifetime. So it's not about us. It's about the reality that we all share. It's about our cosmic neighborhood. It's about looking around and seeing who is out there. And for that, you don't need mathematical gymnastics. You just need to look.
Well, if they want to study that, that's fine. But your project, here's another question about Galileo. It seems like it could have a really practical benefit. There's a NASA Office of Planetary Protection. There's this mandated search for near Earth objects. It seems like you could contribute to that database, right? That's
right. I think we will learn something important irrespective. And we need, I mean, as scientists, if we get good data, we can clear up the fog about unidentified objects. It's like a fishing expedition. We might catch only sardines, things that are
right.
explained as natural phenomena or as human-made. I don't have a problem with that. So the Galileo Project is a big tent. I included people who are skeptics and people who are advocates for an extraterrestrial origin, because I think it's irrelevant what you think in advance.
My point is, can that help do planetary protection? There was just a movie called Don't Look Up. I don't know if you've seen it. It's a great commentary on the human condition and why people don't believe something right in front of them. But right. Can you help find an asteroid that's going to hit Earth?
Oh, definitely. I mean, because we will search for objects, and those that are on trajectories that could intercept the Earth would obviously be noticed. And
right.
By the way, the Pan-STARRS telescope was established in Hawaii to search the sky for objects that may come close to Earth. That was the task that NASA was given by Congress in 2005 to find all objects bigger than 140 meters and that may intercept the Earth. And Pan-STARRS was the first step in that direction. And the next survey, the Vera Rubin Observatory will start operations in a year and could find 60% of those objects bigger than a football field that can cross the orbit of the Earth. And obviously, we are smarter than the dinosaurs that 66 million years ago didn't look up and didn't use telescopes. They were very proud of themselves. They dominated the Earth, and then rock the size of Manhattan Island hit the ground and tarnished their ego trip. And we are actually searching for things that are just 1% of the size of the rock that the Chicxulub impactor that killed the dinosaurs. And so definitely that is part of the Galileo Project, to monitor all the objects out there that will be seen, observed by the Vera Rubin Observatory in Chile. And then we are particularly interested in those that are coming from outside the solar system, that move too fast to be bound to the sun. And then not only those, but those that do not show any cometary tail, that are pushed away from the sun without having a rocket effect, and that resemble Oumuamua, basically dating the next Oumuamua. And then we would like to come close to them and take a close-up photograph.
That sounds extremely exciting. I can't think of anything. I mean, if you find that and demonstrate that it was not natural, that'll change everything. That'll be amazing. So I wish you the best. Hopefully the funding will come. I know in order to make these things happen and get the researchers and undergrads or grad students to work costs money. And as you mentioned, it's a drop in the giant bucket of what we spend on other things that probably don't produce human civilization changing knowledge. So hopefully you can get that done.
We may be on the cusp of a big change in the way we perceive reality, as long as there is funding for the search for these things. And I think the coming years could be transformative. I mean, we are just like the fishermen that cast a net, and whatever we find will be reported in open data that with an analysis that is fully transparent. So I think it's a worthwhile investment, and it's only at the level of hundreds of millions of dollars. So this kind of investment was made in the past, and given the importance for the future of humanity, it definitely needs to be done in the next few years.
It's amazing. Well, best of luck to you. Hopefully I make it back to Cambridge so I can continue some guest lectures on the other side of the Charles River there from where your office is.
Well, you are invited to visit the front porch of my home.
Yeah, right.
Whenever you are around, and we can have a chat. There was actually an interviewer that posted on YouTube a video of an interview that took place a couple of weeks ago. It's freezing here right now, by the way. I jogged this morning, and it was as if the scene was taken out of the surface of a planet outside the habitable zone, because the temperature was minus 20 or so, and it was really freezing. But I go out and enjoy nature, irrespective of what nature is. You see, I really enjoy the challenge of being in the snow, being in the rain, or anything else. And if I see an object, near Earth that looks unusual, you will get the truth from me of what it means. I don't want to assume anything, and I accept nature, whatever it brings.
That's the beauty of science. Just follow the data and see what it is. And if I had all these quotes that you had said, but maybe this is a good one to leave it on. Arthur Conan Doyle and Sherlock Holmes. When you have eliminated all which is impossible, then whatever remains, however improbable, must be truth. And that's a really great logic pattern to use in life. Eliminate everything that you think it is, and whatever's left must be the truth.
Yeah, because we are often drawn to possible explanations that are incorrect. And if you use the evidence to sort out what is correct or what is not, but you have to put all possibilities on the table. If you in advance declare the answer, then unfortunately you will not learn anything new. And that's the mistake the philosophers made in the days of Galileo. Nobody remembers them as a result.
Right. Everybody remembers Galileo, even though the church, arrested him, and they were burning people at the stake.
Yeah. Today he would have been canceled on social media.
Exactly.
I would have invited him to join the Galileo Project, obviously, as an honorary member.
Well, it's a great name. It's a perfect name for a project. So, Dr. Loeb, thank you so much for joining us. This is amazing. And again, if you love the podcast, please don't forget to subscribe and give us a rating.